Good morning to one and all. I am Parthiban working as an assistant professor in the Department of ECE. Now I am going to talk about the subject called satellite communication, which is coming under the regulation R 2021. The subject code is CEC 352. Now I am going to talk about the Unit 2, which is about the frequency reuse and its concept. So what is the necessity of frequency reuse? Why we go for frequency reuse? Generally, a transponder is a device where the channel is independent of the communication path within a satellite. Each channel receives a specific frequency band from the earth and processes it and sends it back to the earth. Satellite is a multi-story building, for example. So each floor we can say one transponder. So multiple users can able to communicate simultaneously. So we have to accommodate all the users at a time. So each channel handles a separate portion of the spectrum. So we go for the multiple channels. Then only we can able to feed the number of users. Because a communication satellite service basically needs the multiple users. Because you can consider a television broadcasting or a telephone service or internet service or data transmission, whatever it may be. So generally we have to accommodate multiple users. So this can be achieved by means of only a frequency reuse only. So generally without frequency reuse we cannot have this in our mind. So the frequency reuse is a one which involves a linear polarization, that is a vertically and horizontally polarized carriers that can be separated, as well as we can also use circular polarization. What is the meaning of polarization is nothing but the orientation given for the electromagnetic waves, or we can say the direction given for the electromagnetic waves. It can be a left hand circular or it can be a right hand circular polarization. Both can be separated. Both can be received by means of same polarized antennas. So because of the carriers with opposite senses of polarization may overlap in frequency, this technique is referred as frequency reuse. So without reuse, we cannot have multiple uses in our mind. Generally, a section of uplink and polarization plan is that is depicted in the diagram. So typically, the transponder architecture consists of a receiver antenna, a wideband antenna, an input multiplexer, as well as demultiplexer, a frequency converter, the power amplifier, as well as the vertical amplifier, as well as the transmit antenna. So the signal flow generally from the earth station to receiver antenna to wideband receiver to input demultiplexer, then channel processing, then coming on to the TWTA, we can say, that is nothing but the traveling wave tube amplifier. After that it is output multiplexed and it has been again transmitted to the antenna and it has been duly received by the earth station. These are the various transponder channels that can be transmitted as well as received with the various frequencies depicted in the diagram. So we are receiving the signal from the antenna and we are transmitting the signal from the antenna. So in between that, the various process steps have been carried out. So the important building blocks are the BPF, the wideband receiver, the input demultiplexer, the power gain blocks, then the output multiplexer. So wideband receiver, as the name itself indicates, so it will improve the bandwidth of the signal as well as it will enhance the quality of the signal. That is the main purpose of wideband receiver. So the signal receiver completely uplink spectrum that we can use. So it will have a low noise amplification, it will have frequency translation, it will improve the signal quality. So why low noise amplification is needed? Because the signal arriving at the satellite are extremely weak. So the distance is enormous. So there will be a path loss that will be there. So we have to compensate for that. For that sake only we are using LNA. So the purpose of LNA is to increase the signal strength with the introduction of minimum noise. That is what the purpose of LNA serves. The importance of LNA, we can say it will have a very low noise figure, it will have a high gain, it will have excellent stability also. Then coming on to the input multiplexer, after the wideband amplification, the satellite receiver large blocks of frequencies. This must be separated into individual transponder channels. This function is performed by the input demultiplexer. So the input demultiplexer will do the above function. Coming on to the input demultiplexer, it will have signals without interface. It will have individual channel processing. It will have frequency allocation also. So it will serve as the frequency bank, we can say. So the advantages of using the multiplexer, input multiplexer, is for channel isolation, for efficient spectrum usage, as well as for independent processing also. So these are the very important aspects that we can say. The signal level progression can be made in this way only. That is clearly depicted in the diagram. The diagram shows the flow of operation of the wideband receiver. So why the not amplify excessively? Too much amplification may cause a saturation, distortion, or intermodulation products. That's why we cannot extremely amplify. Generally, we will use high power amplifiers in satellites, particularly two common amplifiers, namely TWTA and SSPA. Both are widely used. TWTA is nothing but the traveling wave tube amplifier. The full form is TWTA. So it generally serves the stages. The signal power is insufficient, it is needed. A very powerful amplifier is required before transmission. TWTA performs this function. So the historical importance of TWTA lies in its high gain, high efficiency, high output power. So these are the basic needs of microwave devices. So TWTA serves with this purpose only. Then coming on to the working of TWTA, it will have an electron gun that will generate the beam. That electron beam will travel along the RF side, and the energy transfer from the electrons to the RF signal. Then the RF signal emerges with greater power. So the advantages are high gain, high output power, high frequency capability. These are the important aspects of TWTA. Why we go for TWTA technology. So there will be a comparison with SPA also, because both are used in the satellite communication. The technology wise, TWTA uses a vacuum tube, whereas the SSPA uses a solid state device. The power capability is very high for TWTA, whereas for SSPA it is moderate. The efficiency of TWTA is high, whereas SSPA is moderate. The weight is higher for TWTA, the weight is lower for SSPA. So the reliability is very high for TWTA, whereas for SSPA the reliability is also very high. So large satellites will go for TWTA, small satellites may go for SSPA. So these are the important things that I have observed from the transponder, its functionings. So the satellite TWTA shows the various building blocks. Here we can see the heater, the cathode, the grid, the anode structure, and the magnetic amplifiers, as well as the attenuator, as well as the helical structure, and then output that is falling on the collector 1 as well as collector 2. So it similarly resembles as if like a CRO structure. So with that, I am winding up the topic called the satellite communication with TWTA and SSPA amplifiers. These are the various references that I have referred. Thanking you one and all for hearing my lecture. Once again, thank you very much.